The project we'll be talking about today,
The software that we're talking about is
the Commercial Modular Aero Propulsion System Simulation 40K.
The Commercial Modular Aero Propulsion System Simulation 40K.
Or CMAPSS40K for short.
No, this is not a flight simulator. This program is specifically an engine simulation.
This is an engine simulation of a generic commercial aircraft engine like you'd find on any plane that you fly on.
It's a nonlinear, full envelope, physics-based model of a turbofan engine with a realistic controller. The engine can produce about 40,000 pounds of thrust. What one could do, for instance, is if they had a simulation of a 747 airframe, they could attach 4 of our engines to it and then simulate flying around using these realistic engines. We developed CMAPSS40K to help in our work under aviation safety to find ways to use the engine to help an airplane land safely in an emergency.
It allows us to do work in developing new controls algorithms, new diagnostic algorithms, things to enhance the way the engine operates.
One of the biggest contributions of this software is that it provides a common test bed for government, industry, and academia to develop control and diagnostic algorithms for turbofan engines.
CMAPSS40K has a wide number of impressive features.
One of the very nice features of CMAPSS40K is that it allows arbitrarily complex input profiles to be entered, so that, for instance, a complete takeoff, climb, cruise, descent, and landing profile can be used.
What may take an hour of real time can take less than 30 seconds in the simulation.
So the engine can simulate many minutes of flight in only a few seconds.
Data can be entered in numerous ways. You can enter data through an Excel spreadsheet, which allows for easy generation of large, complex flight profiles. You can also enter data through a graphical user interface, which allows you to very easily select and change things like the engine control mode or to change the altitude of the engine.
The health condition of the engine can be changed online in real time so that a fault can be simulated, which is very important for the development and testing of diagnostic algorithms.
The simulation outputs a large amount of data. It outputs things such as the thrust of the engine and the speed of all of the engine components. And these are all displayed on the screen as the simulation runs to allow the user to observe what is happening during cases such as the pilot requesting more thrust.
It allows the user to define and modify the health condition of the engine to simulate a new or aging engine or an engine with a fault.
There are also many other features of the simulation. It has very high fidelity stall margin models for the compressors. These are not typically found in most engine simulations.
Standard engine simulations have the input of fuel flow, but CMAPSS40K has not only fuel flow, but variable stator vane and variable bleed valve inputs.
Linearizing the engine is very simple through the graphical user interface. You can switch to a tab, input the flight condition, as well as the health parameters, and you can select what inputs you want into the open loop engine. You can either choose just the fuel flow and leave all the other inputs scheduled, or you can select to have control of the fuel flow, the variable stator vanes, and the variable bleed valve.
Software development is complete, and it is available for free download through the NASA software repository.
The development of CMAPSS40K has been a very interesting experience. Nonlinear models like this are extremely complicated, and they make for very interesting objects of study. It's been really rewarding to see the whole project come together and to finally be able to release it to the public.
It's been very gratifying to see how people have picked it up, all the excitement that there's been about it, and now that it's publicly available, how many people have downloaded copies for their use.
Our hope is that CMAPSS40K will be used by people in government, industry, and academia to improve the current state-of-the-art in engine controls and diagnostics, making for safer flight.
Because so many control and diagnostic algorithms are being developed using CMAPSS40K, it's quite likely that some of them will eventually find their way on board airplanes, which will make the flying experience even safer than it is today.